Okay, let us see example 2. This is example 2, but I also need this because I'm going to refer to it. So we said for the closest approach, B should be perpendicular to AVB, and AVB is always from A if A is the closest approach. If B is the closest approach, then VB should be perpendicular to V, and the reference will be to A, as simple as that. So this was the first number, and now I'm going to refer to this to handle this. Okay, a ship moving with a constant speed of 24 kilometers per hour in the direction of north 40 degrees towards the east, and initially 10 kilometers from the second ship, the bearing of that. So we first now approach that. So we have one. So we are going to have our ship A here. Is it A? Ship in the direction of north, initially from ship B. So this is our ship B. If this is our ship B, now this one is in the direction of this. So north 30 degrees towards the west. So this is north 30 degrees towards the west. So when we do this, like that, north 30 degrees towards the west. This is our north line there. You have to be careful and follow. Okay, that should be so. When we reach here, this is where our B is going. I mean, that's where our A is going to be. So that's where our A is. So the distance here is 10 kilometers. So this distance is 10 kilometers. Okay. Now they're telling us that this one is moving 20 kilometers per hour in the direction of, this is the direction, north, forward towards the east. So this one is going to be like this. This is north, 40 degrees, because this is our north. North, 40 degrees towards the east. The axis, the direction, I mean the velocity is 24 kilometers per hour. Okay. If B moves with a constant speed of this, find the course B must set as close as possible to A. Now, you see that this one is set in the course to be close as possible to this. All we do, we first get the negative. This is our VA. So the negative of VA is going to be in this direction. So this is our negative of VA. Now we say this should be towards this. The negative velocity is from this, but towards that. And then we say this perpendicular distance here from that point of closest approach. This is our D. So from here up there, we have that shortest distance D. That's going to be our shortest distance D. We say when the direction where this is going, because this one we want to send the closest approach, we first get the negative of this. So then our negative velocity is going to be in that direction. So it's going to be now B, V, A, where this one is going. As simple as that. Now, let us call this angle theta there. Now, as you say, that this one, the velocity of this now should always be perpendicular to this. So let us put that perpendicular. The velocity, this is our V. So this one should be, the velocity now of B should be perpendicular to this. So if I put this to be perpendicular in that sense, so this is my velocity of B, but here this is perpendicular. And this is going to be my velocity of B. Now, where B stops, you can easily put your compass like that. Now, the course we are going to set, we are going to call it alpha. If I set this as alpha, now I bring this force of this very close to this one. So let me bring this velocity of B, I mean of A. So this is our velocity of A. But remember, this velocity of A, here, it was 40 degrees. It means that the balance here is going to be 50 degrees. So, meaning that also here, this is always equal to this. So this is going to be 50 degrees. Now, if this is 50 degrees, note that from here up to here, this is going to be alpha. So what will be the balance? The balance here is going to be, now, remember, if this is 50, it means that from here up to here is going to be 40. From here up to here is 40. So if this is alpha and all of this is 40, then this is going to be 40 minus alpha. Now once you know that, you come and draw that sketch. There you see, this is the velocity of B, this is the velocity of B, then it's going to be meeting at that point. So you draw that. So it's going to be in this order. This is our relative velocity. So this is our B relative to A. Okay, in that direction. Then I need to draw this like that. So this is my velocity of B. Then I also need to put this in this direction. So this is going to be my negative of A. So this angle here, we see that this angle here, the angle, because you know that this is going to be our negative. This is our negative of A. So this is the angle, this is B. So it's that this one is going to come and meet this like that. As long as this is perpendicular. So this is perpendicular to this. And then this angle here was now 40 minus alpha. So when we have that, the rest are okay. So this B, they told us that B is moving at 22 kilometers per hour. So we have also the velocity. This one, the magnitude of the velocity is not changing, it's just the direction that is changing. That's why this one is 24 kilometers per hour, and this one is 22 kilometers per hour. So now, I need to get this angle alpha. I have this, I have this. So this is adjacent, this is hypotenuse. So what am I going to do? I have an adjacent and hypotenuse, so I need this. So there I am going to use cos. So our cos of 40 minus alpha is equal to the adjacent over the hypotenuse. So from there, my 40 minus alpha, cos inverse of that, we are going to be with, so this is 23.56. Now my alpha is now 40. You take this side and bring this side, 23.56, which is 16.44 degrees. And therefore, this is our part A. This is our cos. That is the cos we set from the north line. Therefore, the cos is 16.44 degrees. After getting cos, we come at our part B. Distance between A and B. This is the now. You see, as this one is moving, it's going to be here. So this is the distance we want from here and then this. So we want this distance here. So if I come and I draw that, this is what I have, like that. So, you see this one is going to be my, this one is going to be my B, then this one is going to be, let us call this one C. Let's call this C, and let us call this is going to be our A. So we need this distance here, D. So we need also theta. But the question is, what is our theta? Now, note, from here up to here is theta alpha, and from here up to here is 30, meaning, if the all of this from here up to here is 9, it means we have this and we have this. So our theta is going to be 90. So note that our theta, okay, right here, our theta is going to be, you see it's going to be 90 minus the sum of these two. The sum of this plus this. 30 plus alpha. So our theta here is going to be 30 plus 16.4, which will be 43.56 degrees. So this is our theta. So we have our theta there. From there, you can be able to see it. From there. Now, that means that if I have theta, remember this distance between them, this distance is 10 kilometers. So I have that, and I need this distance. So this is opposite, this is hypotenuse. I have this as 43.56. So you can see that now my sine 43.56 is equal to the opposite over hypotenuse, which is 10. So my B is going to be 10 sine 43.56. And from there, the shortest distance, 10 sine, it's going to be 6.8911. Are they in kilometers? Yeah. Now these are going to be in kilometers. So that's the shortest distance. Okay, so from there, we can come here. Then they are asking us for the time. To get the time, remember to get to this shortest distance, we have covered the distance BC, and using this velocity of B relative to A. So meaning that our time, the time is going to be BC over BA. So these ones are just changing. Okay, so where is my BC? You see that this is my BC. So, I can come here and facilitate ABB. So from here, now all of this is going to be now 40 minus alpha is 23.56. Okay, so we have it there now. So from here, my BC, I'm going to get, let me first get this one. So I have the opposite, I have the hypotenuse. So my sine, or you can, because you want this is opposite, so that's the only way you can use sine. 23.56 is going to be equal to B over the hypotenuse, which is 24. So BA is going to be 24 sine 23.56. My is going to be going to be 9.593 kilometers per hour. When I have this, now I need to get my BC. So we have this. So what about BC? We need this BC. So it's that I have this and I have this. So there I'm going, this is adjacent, this is the hypotenuse. So my cos 43.56 is going to be the adjacent which I want, BC, over the hypotenuse, which is 10. So you can notice that my BC is going to be 10 cos of 43.56. So from here, my BC is going to be 10, which would be 7.2465 kilometers. So after that, then I have my time, which I said is BC over B relative A, which is going to be my BC 7.2465 divided by this, which is 9.5930. And so from there, my time is going to be 0.7554 hours, which we can convert to minutes. 4 times 60. So our time is going to be 45.3 minutes. So that's the time. So it requires this one to move the time that this particle AB is going to move to the closest distance to this BA. It's going to be just 43 minutes. So that's how we handle that. I wish you will learn this idea. When you know how to, the rest are going to be okay. So that's it. I wish you well.